Hi everyone, I hope you're having a wonderful day. This is a recap video emphasizing some important details that you might have missed. And I also go over some small mistakes that I made in the first set of 6 videos. First, let's jump right into explain-00. Okay, here it is. Let's take a look at this first graph over here. When I first explained this, I glossed over some of the math details. First, notice that the horizontal line is the x-axis, and the values increase towards the right. The vertical line here is the y-axis, and the values increase towards the top. Now, let's take a look at the limit formula. Assume that h here is a small positive number, very small positive number. If f of x plus h is greater than f of x, the slope is then positive. Why? Because then you have positive being divided by a positive, which remains positive. Now, on the flip side, if f of x plus h is less than f of x, then the slope becomes negative. Why? Because this value is at the top is negative, so therefore negative divided by a positive is negative. Okay. And this, the positive here part is the slope here. Sorry, the slope here is positive. The slope here is negative. Let me rephrase. The slope here is positive because as you move toward the right, f of x plus h increases. Similarly, as you move towards the right here on the left side, f of x plus h decreases. So remember that typically h is a tiny positive value. We usually don't bother with using negative values for h for the limit formula. Now, about symmetricity. I forgot to mention d of x times y over d of x is obviously y. D of x times y, d of y is x. Try to work this out on your own. It's a pain, I know, but it's a good for you. It's a good kind of pain. And obviously, it's the important thing here is that d of x with respect to d of x is always 1. It is also good to mention that d of x for d of x, d of y, if, for example, if assume that this was some other variable that's different from x and y, then this derivative becomes 0. Meaning, if the variables, if the top and the bottom, if the numerator and the denominator are unrelated to each other, the derivative is 0. Now, in explain-00, I covered the bare essentials of calculus. Okay, just enough to get you over the hump if you haven't officially studied calculus, or if it's been a really long while since you did. If this is the first time you heard of limits, derivatives, and so on and so forth, then you should probably take a Calculus 1 course somewhere. It really will help you understand some of the very strange math that you will encounter. And there's going to be a lot of these guys. Now let's jump ahead to explain-05. Here's the do pass loop. Let's take a quick look at this part below where we update the tensor by adding dash negative LR times P dot grad to it. Remember, this update is usually done as part of the PyTorch optimizer classes. Just keep that in mind for now. I wish we had better terminology than optimizer, but we're sort of stuck with it. The reason why we negate the LR here is that we ultimately want the loss value to decrease. And P dot grad. So why does P dot grad? P dot grad is derivative of d loss with respect to d param or dp. That's the grad field. And remember, generating the grad took multiple steps, right? First, we started with d loss, which was 1, and then we chained it back one layer at a time through the backwards method. So if we update the param p with negative LR times p.grad, we're hopefully going to decrease the loss next time we push in the training data. Okay? Okay, so that finishes the quick review of explain-00 and explain-05. So here's the summary. These are the key takeaways from the first 6 videos. Having a non-linear activation function gives you modern AI. Okay, matrix math plus activation function equals modern artificial intelligence. Okay? And the ability to generate the local gradient with respect to your loss or error is also critically important. Now, for do-pass, I need to emphasize this. Do-pass or something similar to it is basically how you train your neural network. Okay? It does get more complicated, but the basics are the same, meaning the basics itself don't change. So after watching the first 6 videos, you sort of have a secret knowledge about how neural networks actually work. The fundamental concepts are simple, right? The basic pattern repeats in pretty much all of the other AI areas that use neural networks, right? Meaning these concepts hold true for the latest large language models as well. You should feel very good about that. But be aware that I intentionally did not cover a lot of details. The reason is that, at least for now, I think it's more important for you to grasp the high level concepts. It's up to you to spend the time to build up your skill set enough so that you can actually become a competent AI engineer. And there's lots and lots to learn there. And I wish you the best. Thank you, and see you soon.